Hi everyone! One really mind-numbingly stupid pseudoscientific idea is the outright denial of the existence of gravity. You get this from flat earthers, among others. I mean, it's one thing to question the role of gravity in cosmology. Maybe it's not the end-all be-all. Maybe electromagnetism has some role to play that has been understated by the current paradigm. I don't think so myself, but hey, it's fine to question things, and if you can come up with a potential alternative to general relativity in cosmology, great! Just don't expect people to take you seriously until you can demonstrate results. But it's a whole different thing to simply deny the existence of gravity, and of course make a stop in tinfoil hat land along the way. On that note, here's radiant electricity.
Hi guys, this is video about the gravity. So let's first start with this formula, which Newton conceived in the early 1950s.
Great start. FYI, Isaac Newton died in 1727. His Philosophia Naturalis Principia Mathematica, where the law of universal gravitation was first presented, was published in 1687. You should also be aware that Newton's model of gravity is just an approximation. It makes accurate predictions when used within certain well-understood limits, but not in general. It was replaced by Einstein's general theory of relativity in 1915, so about 40 years before you think he came up with it.
So that's two masses, mass 1, mass 2, and this is gravity force, aka attraction force, which cannot be in any way attraction force. And this formula is so stupid, and I am going to prove you, okay?
Just a quick note, as you can hear, this guy's English isn't great. I'm going to overlook that as long as I can understand him, which fortunately I can. But okay, why is it stupid?
So we have this. It is only one mass body, not two, and we have this elusive gravity field.
It's not elusive at all. Place a massive body inside a gravitational field and it will accelerate toward the source of that field. This is perfectly analogous to what happens if you place a positive test charge inside an electric field. It will accelerate in the direction of the field at that point.
And which is only g, universal acceleration, and acceleration cannot be the field.
Why?
Okay, this is formula for the force. You have mass, acceleration, and force, and this force could be electric, magnetic, weak or strong force, or even yes, atomic force, never mind. But it cannot be gravity force, because this is a common expression for the force in general.
That's the point, exactly. Put a body of mass m1 in the gravitational field of another body of mass m2. The force of gravity on the former will be F equals g m1 m2 over r squared. And as you correctly point out, it will also be F equals m1a. This isn't a contradiction. All it means is that g m1 m2 over r squared equals m1a. Dividing both sides by m1, we see that a equals g m2 over r squared. In other words, the mass of the falling body cancels out and has no effect on the rate of acceleration. This is exactly what we observe. How is it stupid to have a theory that matches observations? On another note, you do know that F equals ma is Newton's second law, right? It was actually published together with the law of universal gravitation. You are aware of that, right? You have a problem with one because I guess you don't trust Newton, so you're sure you're cool with the other one? Just checking.
So we have two masses. One mass is larger and other mass is smaller. And we have this elusive gravity force field. So every force in mathematics and physics has to have its force field. And we see that they are parallel here in the same direction, so they should repel each other.
Why?
Okay, these are 2 point charges, electric charges, which are negative. And by default, this line of forces, field forces of electric field, are going inwards. And you see that they are same as the gravity, they are parallel. and in same direction. And we know from electrostatics that this is repulsion force. So this ether streams, so yes, there is ether.
No, there isn't. Not only has this been disproved through direct experiment, but the existence of ether is also incompatible with relativity, which has mountains of evidence in favor of it, in the form of predictions that are successful, but not made by any other theory. Now, before some smartass says it, yes, there are versions of relativity where there is an ether frame, but in those versions the ether frame is completely arbitrary. There's no way to experimentally distinguish an ether frame from a non-ether frame, so it turns out that it's not something that is physically real, it's just a mathematical convention.
So these streams of electric field are repelling each other, thus these bodies are also repelling each other.
A couple of problems. One, field lines are not streams of anything, they are visual representations of fields. The way we draw electric fields is by imagining what would happen if a positive charge were placed in a point in the field. We say that the direction of the field is the direction in which that particle would accelerate, and draw field lines accordingly. This actually shows you that two positive charges will repel each other. They will accelerate in the direction of the other one's electric field. For the same reason, two massive bodies will attract each other due to gravity. 2. One very obvious difference between electricity and gravity is that with electric charges, opposite charges attract and similar charges repel. With gravity, it's the other way around. Mathematically, you see this when the equations for gravitational and Coulomb forces are written out in vector form, r hat being the radially outward pointing unit vector. This means that for masses of similar sign, gravity is attractive. This is why the field lines point inwards. But for charges of similar sign, the Coulomb force is repulsive, just like we observe. Now, whether you understand what I just said or accept that this accurately describes physical reality is irrelevant to the following. If gravity works as described here, then your idea that the field sources must repel each other if the field lines are parallel in the direction perpendicular to the line between the bodies doesn't hold up in general, and spoiler alert, it doesn't. To say that parallel field lines must imply a repulsive force therefore presupposes that gravity does not work as described, which is what you're trying to prove. In other words, your reasoning, and I use that word very loosely, is circular. Where did you get this field lines idea? I mean, the way you present it, yes, it holds true for electric fields and several other fields as well, but the idea that it holds true in general, where did you get that? What you have to do is look at why it holds true for electric fields. Does the same explanation apply to this other field? Maybe it does, maybe it doesn't.
This wire also have this magnetic field which is in this circular motion, and when this electric wire is introduced in this magnetic field, in the magnets, we see that these field force lines are parallel with this wire and with these magnets go in the same direction parallel, thus it's repelling force, and we see this arrow that this wire is going in that direction because of this repelling force.
Same problem. The magnetic force is just like the electric force in that it is opposites that attract.
Okay, these are two magnetic wires. One is going inwards and one is going outwards. It is top view. So you see when these field lines are parallel, it's repulsion force as these arrows indicate.
Just give up. It doesn't matter how many examples you bring up as long as these examples aren't similar to gravity in the relevant way. Now, they can be similar in other ways, but if they're not similar in the relevant way, then you're committing a false analogy fallacy.
Okay, this is the clear example. This is the Earth and this is the Moon. And these both bodies, the aka planets, which are not.
Oh yeah, forgot to mention. This guy's a flat earther. He also believes in free energy.
It is lines of gravity force. And this is according to Newton, but we see that they are parallel, so the Moon and Earth should repel each other.
Okay, one more time. They would repel each other if gravity was a repulsive force. It's not. These are the field lines of a force field where similar signs implies attraction, not opposite signs.
Gravity is repulsive force, according to Newton.
That is the most blatant straw man I have ever encountered.
Okay, yes, it's the two bodies problem. Like, I don't know, binary stars, binary satellites, binary moons, and black holes. So we see the two bodies of equal masses are orbiting each other and all the time avoiding each other. But how can they avoid each other if the gravity is attractive force? They should come together and merge.
It's easier if we start by looking at a very light body orbiting a very massive one, like a spacecraft orbiting the Earth. Why doesn't it fall down? The answer is that it is falling, but it's also moving with a tangential velocity high enough to miss the planet. That's what being in orbit means. Let me break out good old Kerbal Space Program. Yes, I know it's just a game, but it's great for illustrating what I'm talking about. Notice that, as you'd expect, right now the trajectory of this spacecraft is a typical parabolic one, just as if I had thrown a ball. It goes up and comes back down. Now watch what happens when I accelerate. See? As I'm sure you'd expect, the result is that my trajectory now takes me farther. Now watch this. I'll accelerate until my trajectory takes me all around the planet. Oops, I'll miss the planet! It's not that gravity no longer affects the spacecraft. If it didn't, it would just drift away in a straight line. It's that the craft is falling, but like I said, it's moving so fast tangentially that it misses the planet. Now, if we look at two bodies of more similar mass, let's call them A and B, the problem is that as A orbits B, B is also orbiting A, but A keeps moving. And of course, the reverse is also true. The result is that they both end up orbiting their common center of mass, the system's barycenter. But the principle is still exactly the same. Both bodies are falling toward the barycenter, but because of their tangential velocity, they keep missing it. If they didn't have any tangential velocity, then they would crash into each other.
Okay, I'd even say there are no such things as binary moons, binary stars. It's all fiction to justify the gravity.
And there we go. When you know that there is evidence to prove you wrong, claim it's fake and don't bother supporting that claim with any evidence whatsoever. I hate to break it to you, but most stars are binaries, or part of even larger systems. This is easily demonstrated by making astronomical observations over periods of several years, making notes of how stars move. But of course you won't do that, nor will you listen to those who have. To you, the best explanation is that literally every astronomer, professional or amateur, anyone who's bought a telescope and pointed it at the sky, is part of a major conspiracy, the sole purpose of which is being evil, I guess? Because it couldn't possibly be that you're just wrong. I mean, that would be stupid.
Yes, let me zoom in. So you see what the buoyancy is. It's the body submerged in some fluid. Could be gas, fluid, doesn't matter. Maybe even solid, I don't know. So depending on the density, it either floats or either sinks or going up.
Wait? I thought you didn't believe in gravity.
So Newton didn't explain this buoyant force. What is the cause of this buoyant force? Archimedes did derived formulas which are correct, but Archimedes himself didn't explain this.
Oh dear. Buoyancy is the result of a pressure differential. At greater depth, the pressure is greater. That means that the bottom of a submerged body is subjected to a greater pressure than the top of it. That results in a net force pointing upwards. One slight thing though, you may want to ask yourself why pressure is greater at greater depth. I mean, the way you calculate pressure at depth d in a liquid is P equals d rho g, where rho is the density of the liquid and g is the acceleration of the liquid due to, what was it? Gravity! It's interesting that this formula consistently gives accurate results if gravity doesn't exist.
Could it be that this gravity thing is related to mass and density? So maybe what we see as gravity is actually the buoyancy.
No, because buoyancy acts opposite to the direction of gravity.
So let's imagine that there is ether all around us, like in outside this container and inside this container.
This solves nothing. Even if I granted you that the ether could exert a force on the sphere, which it couldn't, even if it existed, which it doesn't, you still have to answer the question of what force is pulling the sphere down.
And we have gravity which is acting downwards. So I guess this gravity which is acting downwards is basically electric force, which is due to electric dipoles in the masses in the object.
Ah, thank you. Now we have something we can work with. So remember what I said about all objects in a gravitational field, at least a locally homogeneous one, falling at the same rate of acceleration? This is something you can test pretty easily, by the way. Take two objects with the same geometry but different mass. Drop them, they'll hit the ground at the same time. In a vacuum, where we don't have to worry about air resistance, it won't even matter what the geometry is. All objects fall at the same rate. This is because, as I explained before, the mass of the falling body cancels out. What would it be like if gravity actually was an attractive Coulomb force? kq1 q2 over r squared equals m1a. The mass doesn't cancel out. In other words, the rate of acceleration depends on the falling object's charge to mass ratio. Since we can significantly change the charge of an object without significantly altering its mass, we easily find that this doesn't match empirical results. As for dipoles specifically, that's when an electrically neutral body has an uneven charge distribution giving it positive and negative poles. It is the dipole moment to mass ratio that matters instead. The dipole moment is basically a measurement of how unevenly the charges are distributed. As I'm sure you've guessed, this cannot explain what we observe as gravity because, just to bring up one very obvious problem, water molecules are polar and have lower mass than both nitrogen and oxygen, both of which are nonpolar. In other words, a prediction of this hypothesis is that in air, which is to 99% made up of those gases, water vapor should sink like a stone. This is obviously not what we observe.
So in chemistry we have a London force, or this is weak electric force between two molecules, and these molecules, these atoms in this molecule
Ions, but whatever.
arrange themselves in order to have positive and negative charged regions, and they attract each other. So in this example we have a table salt. It's a molecule from hydrogen and chloride atoms.
Ions, but whatever.
So this is what gravity really is. This force between two dipoles, nothing else.
Ah, of course, because if dipoles can attract each other, then nothing else can. If dogs are kept as pets, that proves that cats aren't. Another problem with this idea is that Coulomb forces only affect charged bodies. We know, not from Newton, but from Einstein, and this is verified empirically, that gravity bends light. It's a phenomenon called gravitational lensing. The problem is that photons are electrically neutral. It's not that their charges cancel out like in an atom, and thus they could have an electric dipole moment, but that they have no charge at all. As such, light cannot be bent by an electric field, nor can it be red or blue shifted by one. Newton thought that gravity affected mass specifically. Actually, the quantities that matter are momentum and energy density. A body with mass just happens to have a very high energy density due to the mass-energy equivalency, E equals mc squared. This is why gravity affects even objects without mass. It even affects space-time itself. Since neither space-time nor momentum nor energy is electrically charged, this simply could not be the case if you were right. Yet, like I said, empirical evidence supports it. Ergo, you are wrong. Look, if you want to overthrow an established theory, then what you have to do is present a new theory that makes the same successful predictions as the old one, plus new ones that can be shown empirically to be successful and that cannot be made by the old one. That makes your model better, and that is what will cause a paradigm shift. But you can't even make one prediction that either Einstein's model or Newton's model does, because you clearly don't even know what those predictions are. See ya.